Hey guys, in this tutorial I'm going to show you how to set up SDL from the command line, compile it from the command line and run it. I see a lot of tutorials that cover setting up SDL using Visual Studio, but I didn't see anyone that covers it from the command line. I don't use Visual Studio while developing with SDL, and I'm going to show you how I set it up. So here I have a project that I've been working on lately, and this is the usual way I set it up. I have a build folder to store my build files in, like the executable and the debug info files. I have a folder called code that stores my source code. I have one for data, for textures and audio and stuff like that. And I have one for MISC, for miscellaneous things that I don't really care about, to be honest. So this is my usual setup, and I usually have a build.bat script inside of my code folder to compile the source code. Okay, so let's set a similar project up for this tutorial now. I'm gonna call it SDL test. And in here, let's create a folder for code. We don't really need data because we're not gonna have any textures in this example project, but we can create one for build and maybe a MISC to store the file that our debugger creates. And by the way, I'm using Remedy for debugging my projects. You can also use Visual Studio to debug, just to debug. If you're not using it for text editing like me, I'm using 4Coder to edit my source files. Okay, so now that we have this, close that too. Now that we have this project structure inside of code, I'm just going to create a file called sdlgame.c. You can also use C++, doesn't really matter, to be honest, to set it up. Obviously it matters if you prefer C++ to C or something, but in this tutorial we're just going to set it up, initialize it, and see if it works or not. And that's why I'm just going to use C. Okay, we're going to get back to this in a bit, but first obviously we need to download SDL. So to do that, go to libsdl.org and click the SDL releases under the download section. And when you do, you'll come into here, and here we want to get the development libraries for Windows. And I'm using Visual C++, and that's what I'm going to be showing you how to build. If you're using WinWG, you can use that, but the compiler command is going to be a bit different. The switches aren't going to be entirely similar, so you might have to do some extra Googling and research to make it work with WinWG. But click on this, and it's going to install this zip file. I already have it installed, so I'm not really going to use this one, but let's just take a look at it. So once it downloads, you can unzip it like this, and in here you'll have this folder. What I do is I usually copy this or cut it from here to my C directory, and I create a folder called SDL-dev, and in here I just paste it here. And as you can see, I have other SDL libraries like the image and the mixer and the TTF here. And yes, so this is where I store it basically, and this is where I'm gonna access it. And having it in the C directory makes it easier to access. You can also add this folder to your path environment variable if you want to access it from anywhere, basically, but I just keep it here. So now that we have it here, let's go back to our project, which is this SDL test project here. And let's go inside the sdlgame.c file. Okay, so I have some code prepared that I'm just going to copy and paste to here. And this code is very simple. It basically includes SDL.h. It should also include SDL image.h, and it just initializes all of it and just opens up a window, a blank window basically. And here I'm actually using SDL image too, which is also very easy to, if you want to set that up too, which in most cases you do, it's also very similar to what we did. You basically need to go to SDL images website. You need to install the development libraries, and then after that you can just put that inside the SDL dev folder here, like I did. I also did it for the mixer and the TTF, but the process is similar. Not similar, it's identical actually. And then what you need to do to make things easier is, so inside the SDL folder, for example, we have the include folder, which has all the header files that you want to include in your project. And inside the lib folder, you have the library files, .lib and .dll files. You have x64 and x86. x86 is for 32-bit applications. I usually use the 64-bit versions. And what you want to do if you want to use SDL image or SDL mixer is you go into the extension libraries folder, and inside the include, you'll just have one include file, header file. You need to copy that inside the main SDL folder here. So as you can see in here, I actually have the SDL mixer.h, for example. I have the SDL TTF.h. I also have the image somewhere in here, actually. Yep, here. And just like that, you also need to do that for the library files. So inside my main SDL library folder here, I actually have the SDL to TTF.dll, SDL2 TTF.lib, or for image, right? So SDL2 image.lib, SDL2 image.dll. I have all those files from the extension libraries too. So I basically go into here, copy all of this and paste it inside the main SDL folder here. And be sure to not mix x64 and x86 up, because that's going to mess things up when you try to compile it. And this is just so that we can just have all of it in the same folder here. So our compiler command is just going to be simpler. That's the only reason, really. Okay, so once we have that, we have everything we need inside this SDL folder here. And then we can go back to our code. And in here, like I said, this code just creates a window, declares a window and a renderer. We have a function called init, and in init we're trying to init SDL. If that works, we're trying to create a window. If that works, we're trying to create a renderer. And if that works, we're setting the renderer color and initializing image loading, the SDL image part. And we're calling that function from main. And if that works, we have this main loop here that just sets a renderer color, clears the screen, and presents it, basically a blank window. And we have this running loop variable here that we're using to detect when the user presses the cross. In that case, we're checking for the SDL quit event, which is being emitted when that cross is pressed, and in that case we're just stopping the application, and there's just some cleaning up in the end before we exit. So let's save this. Obviously this isn't going to work now because we need to compile our code, and to do that I usually just have a script called build, which I'm going to create now from my text editor. Build.bat. Whoops, nope. I want to create a file, build.bat. Okay. And in here, I also have the command prepared because I don't want to waste your time typing all day. I have this command. I'm going to save. And what this does is basically, okay, so it has echo off, which just means that it's not going to echo the things it's doing from the command line to you. It creates a build folder in case it doesn't exist. And it goes inside that build folder using pushd. And then it compiles the application using the CL command. And then it basically uses popd to get out of the build folder. So the way this works is the CL is the Visual Studio's Visual C++'s compiler name if you want to use it from the command line. In that case, you need to actually have it, you basically need to use the developer command line. And to quickly show that, actually, this wasn't in my plans, but now that I think you should know this because you're trying to compile this from the command line. Let's see. Okay, so I have this shell script here that I run, which sets up the variables that allows you to use the CL command from the command line. So this is what it looks like. And let's actually copy this. To my command prompt here. And if I run it, you'll see that it sets up the environment for x64 because I'm planning to develop 64-bit applications. You can also use x86 for 32-bit. So yeah, you might want to run that before you compile it because it's not going to work because you're not going to be able to access the CL command from here. So the way I do it is actually for my command prompt. In the settings part, I have, okay, here. So in the general section, I added this here, which runs that shell script I shown you, which sets up the command prompt for development, basically. So every time I run this command prompt, that shell script is run, which just calls this command here, which lets me use CL from the command line. If I'm not mistaken, you can also use a developer command prompt, this one, which comes in, which I think it installs itself when you install Visual Studio. And this one will just let you use CL. Yeah, right out of the box. So you can either do it like me, or you can just use the developer command prompt. But here it says it's set it up for x86. So I don't know, you might still need to call this to set it up for x64. So yeah, if you're using x86, I guess this is just fine. But if you want to do 64-bit, do what I just told you. Okay, where were we? I think I was just explaining this command here. Yeah, so we create a build folder, and from that build folder, we're going to compile the application. And we call CL, which is the Visual C++ compiler. We say -zi. This just means give us debug information. You don't need to do it, but if you want to debug your application, you basically have to do that. And then we give it the source file, which in this case is inside the code folder, and it's called sdlgame.c. We have the -i compiler switch, which tells the compiler where to look for the include files. And in this case, we stored it inside the C drive SDL dev, and the name of that SDL folder that we downloaded from the SDL website, and -include. which is just going to look inside here, inside this one, and inside the include folder. So we're basically telling the compiler, hey, when you look for header files, look here first. Then you can look elsewhere. And we also need to do the same for our library files, in which case we say link, and we give it the path to look for, which in this case is in the C drive, SDL dev, and inside the SDL 2016 folder, we give it lib and x64 because we're trying to compile for 64-bit. And after that, we can specify which libraries we want this application to link against. And in terms of SDL, we have SDL2 main.lib, SDL2.lib, and in this case, we're using SDL image.lib. And we're actually not using SDL ttf.lib and SDL mixer.lib, so we can actually get rid of those. And besides that, I'm also linking against user32.lib and shell32.lib. And I think you have to link against those because I think it doesn't work. That's why I have them there. And I just found those with trial and error, actually. And finally, we have a subsystem console, which means that it's going to show you the console. And if you don't want this, you can change this to subsystem window or window, I think. Yeah. So this is the command to compile the application. And if you run it, let's do that from the command line. Let's go inside cd SDL test and cd code. We have the build.bat here. Let's run it. Okay, it looks like it worked. And if it worked, it means that we already had the build folder. So we should have the build here. We do. You can either run it from here, but I usually run it from a debugger. But I guess to make things less complicated, let's just run it from here. And like I said, it's just going to give you a blank window, which means that it worked. Yay. Yeah, so this is it basically. It's really not difficult to set it up from the command line. So to recap all of this, which is a bit chaotic to be honest. So we have our project folder here called SDL test. And inside of here, we have a build folder, a code folder, and a misc folder. Inside the code, we have our source code and a build script. And the build script compiles the code and places the executable inside the build folder. And we also downloaded and placed our SDL development libraries inside the C drive in a folder called SDL dev. And here we basically only need this folder because we copied everything from the extension libraries into here. And inside of this folder, we have the header files inside the include and the library files inside the lib folder. And remember, x64 for 64-bit, x86 for 32-bit applications. So once we have these, we created the build script and our source code, and the source code is very simple. Like I said, it just creates a blank window, initializes SDL, creates a window, a renderer, and initializes image loading so that we know the extension library is also working. And the build script is also very simple. Creates a build folder, compiles the code using this big old command I showed you. And finally, once you run the build script, you have your executable inside the build folder here that you can run from here if you want to. Like I said, I usually use a debugger. I use Remedy. I can also quickly show you how that works. I opened up. I create a command which is going to point to the executable that we just created. And I usually set up a working directory, which is usually the data folder, in which case we didn't create it, but we can just add it here. This just means that the debugger is going to run the application from the data folder. So if you have assets that you want your executable to be next to, you can do it this way instead of just copying your executable inside the data folder. And after this, I'm gonna open up my source file to see my code. And I'm gonna save this configuration inside the MISC folder. And I'll call it SDL test. And it's gonna create a .rdbg file, which is just Remedy's way of storing data. And you can run it from here, from the control, or you can just press F5. And it's gonna run the application. And you can also debug your application from here. You can put breakpoints, run it that way. It's gonna stop. It's gonna let you step over stuff, and that's just good. Okay, so this is it. This is how I set up projects, and this is how I compile them, run them, debug them from the command line using the Visual C++ compiler. And thank you for watching.